Cofunctions are easy in theory, but for some reason difficult to remember. So first off, the idea is if you have complementary angles, meaning they add up to 90 degrees, you're going to have cofunctions. And the reason for it is complementary angles add up to 90 degrees. And if you have a right triangle, remember all triangles, angles add up to 180. Well, if you have a right triangle, you already have 90 degrees right there. So we've got 180 degrees in a triangle. Take away the 90 degrees of that right angle, that leaves 90 degrees left. So that means these two angles right here add up to 90 degrees. So if you have complementary angles, if you put them in a right triangle, they would be one of the two angles there, or the two angles would be in those two spots. A very common one for us is the 30 and the 60. Okay, we use those quite a bit, or the 45 and the 45. We use those a lot too. But every once in a while, they're not going to give us an angle. They're going to say theta, which means the other one they're going to write down as 90 minus theta, because that's how you're going to get that number, right? I mean, if I had to put a 20 here to figure out the other number, you would take 90 minus 20 to get 70. So this is going to be where you're going to look at it and go, oh, that's confusing. I'm not sure what to do. But let's look at why they work. Okay, so I'm just going to put a 30 here and a 60 here just to have something to say. So let's talk about the sine of 30 degrees. Okay, sine of 30 degrees is opposite over hypotenuse, right? Opposite over hypotenuse. Well, let's now talk about the cosine of 60 degrees. Cosine of 60 degrees, remember right here, cosine is adjacent over hypotenuse. And if you'll notice, we talked about the exact same sides. So that means sine of 30 degrees is the same thing as cosine of 60 degrees. Now let's translate that into this guy right here. Sine of theta equals cosine of the other guy, 90 minus theta. Or we could also say cosine of theta equals sine of 90 minus theta, right? Because if we look back here again, cosine of 30 degrees is adjacent, is adjacent over hypotenuse, and sine of 60 degrees is opposite over hypotenuse, and once again we talked about the exact same sides. Okay, so again we've got the sine equaling the cosine of one angle versus the other angle, and then we also have that for tangent. Let me draw another triangle. So if we have our triangle right here, okay, so we have 30 and the 60. Okay, tangent of 30 degrees is opposite over adjacent. So we've got opposite over adjacent. Well, cotangent of 60 degrees, let's get a different color, cotangent of 60 degrees is adjacent over opposite. Remember, we flipped that. Well, for 60 degrees, here's adjacent and here's opposite. So we talked about the exact same sides, whereas the opposite of one is the adjacent of the other, so they match up. All right, so to summarize, we've got the sine of one angle equals the cosine of the other guy. And that's how we would denote the other guy, because we've got this triangle here. This is theta, and this is 90 minus theta. Okay, we've got cosine of one angle equals the sine of the other guy. It's really just saying the same thing, but I'm switching who's the other guy there. And then we've got tangent of one angle equals the cotangent of the other guy. And then the same goes for their reciprocals. Okay, so this is the cosecant equals the secant of the other guy. Okay, secant of one equals the cosecant of the other guy. And then the cotangent equals the tangent of the other guy. And this is cofunctions. And so you'll see this in board problems and all over the place, but that is the nitty-gritty of it. Good luck.